Welcome Statistics 1 students to week 3 of our maintenance. We're carrying on this week again, just doing the representation of data section. So this first question is a past exam question. We've got two chaps who are doing a school statistics project, a particular model of headphones for MP3 players. And the first guy, Ashfaq, I don't know, collected prices from 21 shops, and Kuljit used the internet to collect prices from 163 websites. So for the first chap, now we've got to think of a suitable statistical diagram. Okay, so I think the key detail is the first guy's done 21 prices and the second one's done 163. So probably what they're getting at is a difference here in terms of some diagrams are more appropriate when you've got a small amount of data and others don't. So the first boy or person has done 21, so you could use a stem and leaf for this. And why? Well, you show all data. You can see the spread and the median fairly easily. So that one would be good. You could also probably use a box and whisker here. The next one, name a suitable statistical diagram for the second chap. Now he's got lots more websites, so I'd probably be tempted in this case to use a box and whisker. So because there are a large number of data pieces and shows spread and median. Okay, so that's that one. This next one is a question from a past exam. It's a coding question. This is one of the things students often find difficult. So let's see what we can make of this. We've got the heights, so x centimeters of a group of young children are summarized by this. So we know that sum of every, and that what this means is the sum of each one of those pieces of data minus 100, and we add them all together gives us 72. And if we take the square of each of those, we get 499.2. Now we know that the actual mean height of the children is this, 104.8. And we've got to find the number of children in the group. Okay. Alright, well, what we're going to do is we're going to take this here, which is the sum of all of the heights, and then we're subtracting 72. We're subtracting 100 from each of those, and when when we add them all together, we get 72. Now, if we take all of those and divide that by n, the number of children that we've got, that will give us the mean of the children once you've taken 100 off each of them. So if all we need to do then is add 100 to that value to give us the actual mean of the children. Whoops, 104.8. So let's just go over that again. So let's say we had, for example, we had 3 children. Say we had 104.6, 104.8, and 104. Let's say, or what will it be? I guess 105. Okay, those are the 3 heights of the children. And obviously this is not going to be true because it's not going to add to 70. But what we've done to each piece of data is we've taken 100 off. So this would become 4.6, and this one will become 4.8, and this one will become 5. And you see the mean of those, the middle the mean, if we add them all together and divide by 3, we get 4.8. Now to get back to the original mean, which is this up here, we just have to add 100. So that's what I'm doing over here, right? I add all of their data together, and remember they've subtracted 100 from each piece of data. I divide it by however many pieces there are. I add 100 to it, and then I would get the original mean of 104.8. That looks a bit messy. Okay, and that means this bit here we can rewrite as 72 over n plus 100 equals 104.8. And what I can now do is let's pop this over here. So I can go 72 over n is equal to, now I'll bring that 100 across by subtracting, so I get 4.8. And then 72 is equal to 4.8 n. So n equals, now we're going to go 72 divided by 4.8. And that gives me 15. N is 15. So there are 15 children in this case. Okay, so that's that one. Now, things look like they're going to get a little bit more tricky now. Okay. We've got to find the sum of x minus 104.8 squared. Okay, so what we're going to do for this is we're going to find the variance. Okay. Now we know the variance of the original data is going to be equal to, well, let's just remember our variance formula. So it's sum of, it's going to be sum of x minus 100 all squared over n minus the mean, which is this, x minus 100 over n and mean squared. Okay, that's what we're trying to get. So now we actually know what the variance is for our original data. So this bit here we know is 499.2. So alright, 499.2. And of course the n we found in the previous question to be 15. So I can pop that in. Minus, now, this bit here, the x, sum of x minus 100, of course, is up here. So that's at 72. Over 15, and then we're going to square that. Okay, so we're just going to chuck that in the calculator and find out what we get. What do we get? 499.2 over 15. Subtract, and then I'm just going to chuck this in brackets. What is it? 72 over 15. Square that. Okay, so that gives us 10.24. Now, the spread of data that has just been moved is going to be the same. So what I mean by just been moved is, if you look at this here, what we're doing to each piece of data is we're subtracting 104.8. So imagine you have a piece of data, some data like this, right? They're all 2 squares apart. If we subtract the same amount from each of them, let's say we subtract 2 from each of them, this one here will be back to here. Oh, whoops, let's maybe change color. So this one will go to here, this one will go to here, and this one will go to here, right? So the spread of the data will remain exactly the same, and variance is a measure of spread. So we know we can take this 10.24 that we've already got and use the new this here where we're taking away 104.8. We can put that into a variance formula. So variance of this data should be 10.24 as well. We're going to take the thing that we don't know and we're trying to find out, x minus 104.8 squared. We know that n is still 15. then we're going to subtract the mean. Now, we're going to go that x minus 104.8, that's our mean. We're going to divide it by n, and then we would square that whole thing. Now, this is where it gets a little bit interesting. If the mean height, which we found up here, we're told the mean height is 104.8. If we subtract 104.8 from everything, what's the new mean height going to be? 0. Okay, so our next line, we can chuck, we should have said this is all equal to 10.24 because the variance will remain the same. Now, well, let's chuck in some data here. Well, we don't know what this is. That's what we're trying to find. We know that this whole thing here is 0. And we've got 10.24 here. Well, we can ignore that 0. And therefore, we just multiply both sides by 15 to get sum of x minus 104.8 squared is equal to 15 times 10.24. And that's giving me 153.6, or 154 to 3 significant figures. Okie dokie, I hope that makes sense. Those coded questions are sometimes quite tricky. Now, good old Bradley, he's got some choice on his way to work, different choices, and we are trying to calculate the mean and the standard deviation of each set of journey times. Okay, so town mean. We add all of these together at the top. Now what do we get when we do that? 15, 16, 31, 20, 28, and 21. So I'm getting 100. There's 100. And how many trips has he had? That looks like 5. So 100 divided by 5 is 20. The country mean. I'm going to add all of these up here. So what do we get? 19, 21, 20, 22, 18. Oh, okay, that's also 100. Which means the means are the same. Okay, now we're going to do the standard deviation. So, town. Why do I keep on spelling it toe? Town standard deviation. Okay. Now, again, you can do this on your calculator. There's a special button that does it, which I probably will have shown you by the stage. But I'm going to do the slow method. So, the sum of x squared. So I'm taking all of these and squaring them over the number of pieces of data. Subtract the mean squared. Now we found out the mean in the previous part of the question. Now if we chuck this into the old calculator, what do we get? 15 squared plus 16 squared plus 20 squared plus 28 squared plus 21 squared all over 5 minus 20 squared, or 400. Take the square root of all of that. Now this is giving me 4.60 to 3 significant figures. And we're in minutes here, I think. Yep. Now let's look at the country standard deviation. Remember, this is spread we're talking about. How spread out is the data. So what are we going to do here? Exactly the same thing, but just use the country data. So 19 squared plus 21 squared plus 20 squared plus 22 squared plus 18 squared all over 5. Subtract, and again the mean was the same, so subtract 20 squared. Now what does this give us? So chuck it into the old calculator. 19 squared plus 21 squared plus 20 squared plus 22 squared plus 18 squared all over 5, and we're going to subtract the 20 squared from that, and I'm getting I'll square it to a 1.41 to 3 significant figures, I think. 1.41 minutes. Okay, so this data is less spread out, the country data. Now, which route would we recommend? The country route is best. Now, why is that? Well, they have the same mean, but the standard deviation of the country route is lower, meaning the route has more consistent times. Consistent times. Okay, and that'd probably be something like that they're looking for, I think. It's less variable is the country route. Now, is that all that we've got? Yeah, that is all that we've got. So that's week 3 maintenance for you guys. I hope that makes sense. Hit me up in the comments if you are struggling to understand anything there, and I'll do what I can to help you. Alright, take care.